Go. All right, class, let's continue. Last few pieces of 1.1, right? Last few pieces here. I'm not sure. Let's see if we get somewhere here. This is 51 to 54, so a little bit more with graphing. Is this whole concept of transformations. Quick question to you guys. Did you guys do transformations?
Yes. We did that in geometry.
Geometry? Okay.
No, we did an algebra one.
Algebra 1? Okay.
I recognize that from more recently.
Uh-huh.
We did it.
We did it, yeah. So here it is. There's a diamond shape right here. And we are going to move this guy from the gray one. Guys, real quick here. The gray one to the black outline here. So we are given the coordinates of the gray figure. We just need to figure out what are the coordinates of the black figure at that point. We're good. So quick little review of transformations here. Da, da, da. So I guess if you want to take the time just to draw it out first, draw out the initial one. And then maybe put this little whole concept of 6 units to the right and 3 units down. We're going to do that one there. Sorry, guys.
I'm so confused.
So we have the gray figure that is given. And what we want to do is we want to go from the gray figure, we're going to go 3 units down, we're going to go 6 to the right, and we're going to produce the coordinates of the black figure, of the black diamond there. Black diamonds. Quick story as you guys do that. Let me do the first one for you, and I'll just talk about a story. So what we do is we figure out the coordinate here, which is this little top coordinate, -3, 6. And what we're going to do is we're going to have to go 3 units down and then 6 units to the right. X coordinates, you guys talked to me, X coordinates, they control the up and down or the right and left? Right and left, so we're going to take that little -3, we're going to add 6 to it because we're using that. So it's really just individual coordinates moving, right? So we're going to add 6 to the X coordinate. We are going to, anybody? Subtract 3 for the Y coordinate, and we should get something called an answer. And you can kind of tell what it's going to be because of the figure, but you just want to just be able to do the work and then verify it by the figure. So everybody okay with, let's see, 3 looks like, and 3. And if you look at the figure, 1, 2, 3, 1, 2, 3, that's kind of where that guy is there. We're good? Just real quick here, all yours. I see a couple of blank stares at the board, so I want to know if you guys are not tracking with me or something's going wrong. Can you guys do the other 3 points? That's your job, if you haven't done it already. Raise your hand if you're done. No, good. You guys do that, I'll tell you a story. Let's see, black diamonds. So this person, about 75 years ago, he was mining for diamonds in Africa. And he comes along about, it's diamond, he can tell it's a diamond, right? But it's black. And most likely it was mixed with charcoal or soot. And so, but it's actually a diamond. So you're like, man, discover this. How in the world am I going to market this? And so he's like, that's okay. So he goes back to Europe and he starts marketing as black diamonds. This is awesome. And not a single person buys them. Like, why would I want to buy a sooted diamond when I could buy one that's actually clear and that dumb? And so he's like, man, I'm holding this reservoir of all these diamonds. What am I going to do? So then he goes to the biggest seller of diamonds in London. And he says, look, I'm going to partner with you. It's a 50-50 split. You advertise this like crazy and we'll split the profits. So he's like, okay. So what he does in the store windows is like all the fashion, all the rage, right? You got all these mannequin hands, right? And that was these black diamonds. on him, and then he gives some away to the aristocrats in London, and all of a sudden everybody's buying black diamonds for like the next 20 years, and then it fades away into oblivion because it's still diamonds that's covered in charcoal soot. So anyways, that's my story about black diamonds. Good. Okay, so you can pretty much sell about anything at that point, right? As long as you market it well. Okay, are we done?
You could just make those into even more diamond diamonds. It's possible to make diamonds out of charcoal.
Okay.
Because it's all coal, or not coal, sorry, carbon.
Mm-hmm. Just depends how you put the carbon together, right? So -1,3, this guy here gets transferred to here. So that's 5, 0. Let's see, this one, which is -5, 3, should be transferred to here. So -5, 3, again, adding 6 to it, subtracting 3 from the other one, and we get ourselves what we want is 1, 0, and we verified by the graph itself. Good, pretty easy stuff. And last one, the bottom should be -3, 0. Let's see, adding 6 to it, subtracting 3, and voila, we should wind up with 3, -3.
Wait, why are you adding 6 to it?
Because of this moving to the right.
Oh, okay.
Yeah, if it was moving to the left, we'd be subtracting 6. And if it was moving up, we'd be adding 3. Okay, we're good there. That's the last part of that piece. And then, let's see, what's the last, 1.1, the last few little thing is just a quick review of geometry, 2-dimensional figures and 3-dimensional figures, right? And then we're done with 1.1.
Is the homework due when we get back, or?
That is so cool. So as far as homework is concerned, if you guys want to write these down as we talk about homework. So I got 2-dimensional, and then the next one is 3-dimensional. Just a quick review about geometry. Here's your formulas for them. If you want to write them down, they're also in the textbooks. If you don't want to write them down, that's cool too. Homework. So the way I do homework is when we finish a section, you have that time to do the section. The next class period we have, I ask for any last minute homework questions on that section, and then it's due that evening. Good. So in this case, it's kind of funky because we have a week vacation on our hands, right? So it would be, we are finished on Friday with this section. Then you come back with any last minute homework questions on Monday, and then it's due Monday evening too. Oh, sorry, hold on, not due Monday evening, right? That's right. Then I pick it up the next day, which is Wednesday. That's right, as paper.
Next week Monday or
Next.
Well, in this case, it's gonna be next Monday.
Okay.
Right.
So
Sorry, yeah, I'm collecting. Keep on thinking I'm doing it. So it's gonna be the Wednesday after. All right, raise your hand if you are going to camp. Okay, all set to go or going. Oh, cool. Okay, raise your hand if you're not going to camp. You're going to be a rebel. Like, heck no. Okay. Getting extra sleep, is that what it is?
I'm actually going on a week-long vacation.
Oh, got it. Okay, cool. You mind telling us, Len, you mind telling us where you're going? We might join you or no?
I'm going to Cabo, Mexico.
Oh, yeah, okay.
I went to
You like it?
Mexico.
Oh, when does Quest, oh, Quest already started, right?
Yeah.
Yeah, that's right. So you got college classes. Gotcha. Okay. All right, class, how we doing here? Those that wanted to write it down are good. Anybody else writing it down that hasn't finished yet? Go once, going twice. So 2-dimensional figures, there they are. This is just a quick review from geometry. There's your formulas, and then you guys know this one, right? The perimeter formula for triangle, you just add up all the sides, right? That's the one that sometimes is not as clearly defined. Okay, 3-dimensional, let's go. How to draw these guys real quick here. 3-dimensional, the way I draw a rectangular solid usually is like this. You draw a face to it, and then what you do, you draw another one just like it, just off center. And then what you do is you collect them like you connect it like this, and voila, it looks like a nice little cube. Another way that you can do it is you can put when you do this outside stuff right here, the inside, you put dash marks, and then you kind of know which ones. Right, you do that right there, then you have these little dash marks, but it's probably the easiest way to draw. Okay, cylinder, that's easy. Two top and a bottom, and then just connect them down. Voila, and the sphere. Sphere usually is a big old thing like this, and then we kind of just round up like that. Just a nice little curve on the back side.
Just a circle with a curve.
Kind of gives you a little bit of a three-dimensional look to it. That's it. Okay, and formula is given. Dun, da, 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 da.
I think that it's funny that we cube it even though it's a circle.
Very true. Let's see. I just real quick here. It is because it's what, three-dimensional, right?
Yeah.
Because technically, right here, there's a 1, 2, and 3,
Yeah.
and then the cylinder is the one that's the funny one. But yes, because the H and the R, two different variables, eventually it becomes 3.
I think it's funny that you don't cube a cube, but you cube a sphere.
Just the semantics of the language, right? Yeah. Okay, and let's jam. Got one for you. Here it is. Oh, tell me, anybody still need time to finish? Going once, going twice?
30 seconds.
Yeah, sure, absolutely. Go ahead. You guys, this is for you guys. Look, I just want to say, I teach you guys. I don't teach math, right? So it's like, this is faster for you, not for me just to get through the lecture before the end.
Okay, I'm done.
Awesome.
That was fun.
Da-da-da. Okay, we got a length of a tank. Let's see. All yours, diameter of a cylindrical propane tank, guys, real quick here, is 4 feet. I got the total volume of this tank is 603.2 cubic feet. Can you find the length of this tank? That's what I need.
Oh no, wait, could you go back to the page before?
Yeah.
That one. So when we do that,
Okay.
tell which one you need. We need the middle one, right? Yeah, middle one. So volume is pi r squared h.
Okay.
Cool. And this one, on these homework questions, you probably do need a calculator to finish it off. So if you have one, that's great. If not, then just wait for others in the class to give you the answer. But before you do that, can you guys set up the equation, right? Can you solve the equation algebraically and then use your calculator?
And I know,
We're running
I
close to
feel
batteries.
for a piece of.
Your batteries are low.
All right, so try this first here. Try to solve the problem first. Set up the equation, plug in the equation, and solve for the variable you need to, right? Before you use the calculator, right? So I'm thinking, let's see, drawing it out first. So if you can draw a diagram of what you need, that's even better. And this one says the diameter is 4 feet. So this guy's reaching all the way across. Boom, and then we already gave the formula. Formula is V is pi r squared h. That's cool. All yours for that one. Give you guys a head start, like 30 seconds. Plug in what you know. And can you solve for the variable that you don't know?
I can't do past a certain point. Well, I could, but it would take way too long.
On the diagram, I just put 4 feet, and then the volume is this one right here. So I just got all the numbers that I want out of it. And then formula given.
Yeah.
And plug in formula 603.2. I kept pi the same. I just kind of did it like that. So pi is there initially still. I don't want to take it 3.14 yet. And your calculator should have a little pi button next to it. Is that right?
Shouldn't it actually be 2 squared because the radius is half of the diameter?
That's right. Hold on. Oh, bummer. 1 second. Let's back up here. This is diameter. If that's D, then R has to be. Who put a 4? Okay,
Something squared it would be
okay,
four.
you put a 4.
Square, wouldn't it still be 4?
Still be 4,
But you
absolutely
wouldn't square it again.
correct. So pi 2 squared h is good by me. Simplify as much as we can first. So this guy becomes 4. So how about a 4 pi h on the right hand side? Are we good there?
It's just,
What should we do next? I'm thinking divide by 4 pi. Okay, and let's have a little calculator. So h is here. I like to put my variable that I solve for on the left-hand side right away, because I'm going to get an answer here. So on your calculators, let's try this here. Let me just do a few variations here. If you do this, this will be wrong. And then you guys have a pi button? Okay, real quick here. This is going to be wrong on your calculator. Anybody tell me how come that's going to be wrong on the calculator? No.
because it will use, it will go by, by division first. In this case, and then multiplication.
Yeah.
Because there's no parentheses.
Yeah, right here, here's your only division because that 4, that pi is not being.
Look, it's the cripple.
He's really confused.
It's not class, we should have to-
Where is this? There it is. Okay.
He's very late.
It
is.
not.
Oh my God.
It didn't even mean.
I can see him in the reflection of the window.
Wow, I can't believe you guys are right.
Oh.
There it is.
That like never happened.
We're good? Let's GM here. So if you do this here, 603.2 divided by 4 times pi, and pi button should be on there somewhere on your calculator. Okay, that guy's wrong. We good? Don't do it that way.
Yeah.
That looks good.
First of all, yeah, that length is way too long. Or the height. The reason is because you need to put the 4 and the pi together as one piece, right? So let's do this here. You can do divide by 4. You can do it that way, and then also divide by pi if you want to kind of separate them out like that. That's cool. The better way to do it is just 603.2. And then whenever you have 2 or more terms, you just put parentheses here. So now this is 4 times pi. And before I click on it, tell me if you get 48, if you did it this way. Okay, how many did it in 2 steps? How many did it in 1 single step with the parenthesis inside it? Okay, Jam, we got 48 on our hands.
Incredible.
Totally cool. Okay, so I'm gonna go like this. Big old parenthesis right here, or do it in 2 steps. But we got ourselves 48, I don't know, what? Elephants, cardboards, Vitruvians, how many? What are we doing?
Yeah.
Wait a
Feet,
moment.
okay, cool.
No feet, ew.
Okay.
No.
Dude. I am
What is he talking about?
Meters.
Why are they so, you know, gas tanks are over feet.
They're measured in Vitruvians, I thought.
I know, yeah.
Okay, class, real quick, done with 1.1. I am gonna just start 1.2. Luke and Elijah, if you guys can quiet down just a bit here in the back, so we can keep on jamming. 1.2, let's start this real quick here as well, just so, because we're just getting through stuff from Algebra 1. And we got 10 minutes? Let's 10 minutes. Let's see how far we get in 10 minutes. This is just graphing lines, talking about intercepts, talking about symmetry, talking about the general equation of a circle. So remember, graphing by tables is like the plainest way of doing stuff, right? Where we get a whole bunch of points, we go from there, review. If you guys are bored out of your minds, good, because this should be it. Did Joe find a time? Yes, you are here.
I was about to be in here.
Yeah, only 10 minutes left of class.
Yeah.
I know.
It's fine, you're privileged. We'll just move
Yeah,
on.
no, I'm careful. I
You get to go to the
I had to walk this.
That was funny.
I don't believe.
How's your walk to school, Joe?
No, I. I saw a rocket blow up. Nice.
Cool. All right, let's jam. So this is 1.2 graphs and equations. You don't need to write all that stuff down on the side. That's just what we're gonna do here. So graphing by table, I know you guys know how to do this. We're just gonna quickly review that. And then 1.3, we actually get into y equals mx plus b, and you're gonna do all that stuff here. So let's jam. Graphing by table, here it is. Can you graph this guy by table? Of course, there's fractions inside it, just to mess with you. So let's do this here, just so we can go a little faster. Can we have 1, 2, 3, 4, 5? Lily,
Which one?
both,
Okay.
and Violet, right?
Yeah.
Cool. If you guys can do -2, just so we do it as a class here. The guys in the back, if you guys can do 0, really tough.
Oh, yeah.
I understand. The 4 guys in the back over there, can you guys do? No, actually, no. Hawking and Elijah, can you guys do 1? Noah and Joe, just to mess with you, can you guys do 4/3? And Elika and Amelia, can you guys do 2? And tell me when you guys get it.
Yeah, so it's 3 minus 1.
Tell me when you got it. No way. Wow.
We are incredibly skilled.
Without writing anything down too. You guys are jamming.
0 was just really difficult on.
Oh, you just said 1.34 times during this.
Girls,
This is
Just
what we're
there,
doing.
everyone else
Like
is
how,
there.
yeah, what we're doing on the table.
Sure,
My
sure.
0 is well.
-2 is the plug-in.
Okay, we're done.
That's like,
Zero.
oh, because we were just like. So
Elika and Amelia,
Amelia and I got 1/2.
1/2. Okay.
This was the most difficult question ever on how to create this. Honestly, I'm sure about it.
Guys in the back.
You got -1/4. For y. You got 1 and -1.
Perfect for the coordinate. Awesome. And how about this? Can we reduce this guy? So 4 and 2 can be reduced a little bit here. So that becomes 2, that becomes -1. So that's gonna be -3/2 minus 1. You guys did get the most difficult one, sorry. Should have given it to the guys in the back. Let's see, moving this to a plus and minus, and then getting common denominators, which would probably be 2, right? So I got negative. And you guys talk to me, is that true?
I don't know, I'm behind.
So this is just canceling top and bottom or reducing, getting common denominators here.
Seems right.
Seems right? Okay.
Yeah.
Okay, real quick here, can you guys graph it? Noah, can you graph it?
Yeah, no.
If you haven't done already.
No, that's your job.
Biggest number here is 2, no, 2.5, huh? So I'm gonna go out to 3. graphing all the points. And then when you do that, you can sketch the graph of the equation, which is
What is the first one? Is that 5/2?
negative 5/2.
So what if you can't read any of them? Yeah.
Then you need to go back to kindergarten if you can't read.
No, like I can't see them.
Oh,
Yeah. I can read them, just like.
I'm struggling with most things.
yeah,
There. Okay.
Oh.
just mess with it, you know.
That is, I feel less blind now, yeah.
Go ahead, Noah, ask question.
Why is it -2/5/2 and not 2 over?
Just makes a straight line.
No, 5 over 1.5.
5/1.5. You talk about the first one?
Yeah, no, 4 over 1. The 4 over 1/2.
Which one, Noah? Which one? First one?
Very first one.
First one, yeah, because it's what, 3/4 is the equation,
Oh, okay, wait, no.
and you're plugging in -2 for the x.
I don't know what I'm thinking.
No problem. No problem whatsoever.
This is literally just a line.
Hold on. Again, too easy. We're gonna do this. We're 1.2 again is just a review of algebra 1, so this should be super easy. Okay, all done with the graph.
Oh, I see over there.
0, -1, 1, -1/4. Is that about right there? 4 over 3.
Yeah.
4/3, 0, 2, 1/2. Boom. And let's talk about this just for a second here. So Descartes in the year 500, 1560s or so like that, right? He invented this system right here. Notice that this is technically an algebra problem because it has numbers associated. That's an equation, isn't it? That's an algebra thing.
Yeah.
So by looking at a fly on the ceiling, he figured, look, I can make a little coordinate system like this. And what he did is he really fused algebra and geometry together. This is it. They're now together from now on. So if I say, can you give me all the solutions of this equation? We could be here for the rest of our lives doing this problem. Right? Because all the solutions are here. Can I put some more solutions? Say again, no? Say again? That's true, yeah. So what happens is this is an algebra problem. It says, can you sketch for me all these solutions to this equation? If you want to list them for me, we'll be here forever, right? Still listing the answers. But since we have fused algebra and geometry together, what we do is we can put all these little dots on this little line right here. And that little line is the solution set to all these problems. So it allows us to have a way to visualize all the answers possible for that equation, all the facts. We didn't even talk about square roots. Are there square root answers here? Absolutely, right? But by having this little graph, so that little line represents all the solutions in algebra for that equation right here. Okay, with that, you stop for the day. All right, those are going to camp, enjoy camp. And see you guys in a little while. Like